So, can you take a look over here and guess at what she does? Last 30 minutes, I want your energy, you know, so a bit louder. Chef, right, exactly, okay. Chef, right. What do you think she does? Firefighter, awesome. What about him?
Vendor.
Come on, you can say it. I promise I will not judge you. If you had to take 2 guesses. So if I were you, I would say IT guy or a doctor, right? So this is magic. I could potentially look at that and say the same thing. So the one thing that we forget is there are millions of people like me who are IT guys and doctors out of more than 1 billion on the planet, all right? And when we were in this room, we somehow thought of 2 professions, and that is because the society that we live in or the people who we interact with in some way creates an impact on us. And what that does is it creates a set of biases that we tend to fall forwards for, and then our mind tends to take a shortcut and whatever kind it is, and then come up with an answer. So over here, availability bias about things that you know about a particular individual or a particular segment tends to give you an influence over your decisions about what you want to do. Not a trick question, so I'm not asking you to think too much, but 2 plus 2, very simple, it is 4, right? Now I'm going to jog your brains a little bit. You could potentially do this mathematical problem without any issue at all. And the thing is, a bunch of us have different ways of doing it, right? We either do it the classic way of mathematics where we carry over a number over there and do it, or you might be a speed math kind of a guy, and you might try to solve the problem by breaking it down, and eventually you will get the answer. What about this? Does anybody know the answer to these summing of these 2 numbers? And this is the question I do not want to see any hands raised for, right? And the reason is, if you knew, you were either a mathematical savant or you had access to my deck before. So, and this is where you need to ask me, like, why do I need to add these 2 numbers? Because that's what you should be thinking about. Like, why do I need to add 2 large numbers? Because the question can be different. And if the question was, is the sum greater than 10 million? Do you now need to add the 2 numbers? No, because you already know both the numbers are more than 7 digits long. The probability of getting a sum more than 7 digits is 100%. So you don't have to add any numbers, and you make a good mental shortcut and immediately come up with an answer. Of course, the sum is greater than 10 million without doing a complex math problem. Good afternoon. Welcome to the last session of SREcon Asia Pacific 2018. I'm glad I'm closing it out for you with a message. And I'm going to talk about mental models. And you already have an idea from the past couple of talks we had. Lindsay spoke at great length about some models. I'm glad because I don't have to cover a lot of fundamentals, System 1 and System 2, so you are all familiar with that terminology. And just to be clear, that URL over there might say I'm mental, I'm not. And I am not the resident psychologist for my team either. So I'm just somebody on my team who actually is fascinated with how psychology can be a part of our engineering processes and site reliability that we do. And this is my take on how it can be used to be more effective at our work. So this is not a tech talk, by the way. So you will not see any more technology beyond this. And that should be the 2 plus 2 and the addition and subtraction or whatever it was should be the end of it. So to take a step back, the goals of our life and the brain is to reduce cognitive load. And when I say reduce cognitive load, we do not want to work. Humans are lazy by definition. That makes us good and also makes us bad. And that is the key of our survival and of our being efficient and good human beings, and we need to accept that, right? Some shortcuts are good, like the mathematical problem we looked at. That was a good shortcut, right? And then there is another kind of shortcut. Those can tend to be, bad to a range of grayscale, which is the kind of example I showed the first time. So that is what you need to keep in mind. Then mental models can be basically three things. They are either habits and routines that we either should follow or should be cognizant of. They could either be frameworks that allow us to define a problem and then interpret it in a specific manner. And the third, they can be mental representations that allow us to remember an outcome for a very, very long period of time, so that next time when we see a similar issue happen, we are pretty much clear about how that needs to be handled. And with that, I'm going to take you to airplane architecture. So I'm going to take you back in time. Close your eyes. You are right at the Second World War. You are no longer site reliability engineers, and you are airplane reliability engineers, okay? And I'm your commander, and I said, make sure that no plane falls off the skies, and your duty is to do that. And all of you are running left and right, trying to collect data on the airfield and figuring out, how to armor the planes up. You have a bunch of armor, and you have to secure those planes. You do that for quite some time, and then you come up with an answer to me and say, yep, figured it out. We know this is the armor. I'm going to patch it up right over here. So and by the way, this is a true story, okay? So what the commander did was, hold on. Let me talk to a mathematician, and he will tell me whether the conclusions that you've drawn is right or not. So you said, this is where the stuff is. I'm going to patch it up. And then the mathematician says, what the heck have you been doing? Like, why were there no bullet holes on the engines and the nose? And the guy was like, we didn't find any planes that had bullet holes in them, right? So the mathematician says, because those planes never made it back. So you cannot put armor in the places where there's no engines or nose cone, because that is where you do not have the potential of having the plane come back to the airfield. So this is what is called survivorship bias, where we are extremely biased towards things that make it through. Startups are another example where whatever makes it through is what keeps us pretty much biased towards them. On our SRE side, there's this problem that Kumar mentioned in his talk. It's about availability, and one of the classic things over here was there was a bunch of missing traffic on the far left-hand side, and because of that missing traffic, availability was not interpreted as it should have been. So what happened was we tended to calculate availability by the amount of requests that came in. We never even looked at the requests that did not make it to our entry point. So this is a way where survivorship bias actually negatively affects our metrics and how it can actually make your product a little bit worse. Moving on from planes to coins. When you toss a fair coin, what is the probability of heads? 50-50, right? 0.5. And if I toss the same coin 100 times, the probability of heads at the 101st time is 50. So basic probability theory over here, independent events and 50%. But if I told you as a next data point that the past 100 heads were there, none of them were tails at all. Now will your answer change? Mathematics tells you that it should still be a heads or a tails equal probability. But really what you should be telling me is, Mohit, that coin is not fair. Something is off. You cannot actually have 100 continuous heads. While mathematics says that, it may not be possible. This is called Ludecke fallacy. Something that is mathematically true might apply in a different way in our real life, and it can have a different outcome altogether. So whatever we do in our labs, in our experiment, in our test infrastructure, does not reflect what can happen in production. So an example from our reliability industry, for context, folks who might not know, healthcare.gov is the federal website where the affordable healthcare plans, health plans for the United States citizens is sent. And a lot of folks from this community actually had to go fix the website and get the system working in order like about 6-7 years ago, I think. So if you look at the highlighted statement over there, it says the website login feature had less capacity than the feature after it. Like, how do you design a system where the login has less capacity than the registration site itself? So that is number one, because you did not think about in practice. It was just test. The funnier one is the one that's not highlighted. I just realized that later on. Due to poor planning, the same login method was used by website technicians, making it difficult for them to log in and troubleshoot. They never thought how that system that they designed would actually be behaving in production and how you can actually use it to make changes later on when it's actually seeing issues. So something to be aware of. How many of you have heard of Tay? I mean, this was not something to be proud about. So again, this is a classic example where you think AI is going to function really well the way you've designed it, but when you let it out in the world, it is not going to behave the way you expect it to. So this is something which is very current for us, for our technology, and as SREs, we need to be aware of what we need to do. One of the Google talks, I believe, mentioned about how there needs to be AI models and ethics and such to make sure things are appropriately measured. So there's an inside joke that we had based on this model. And we said I need to add a new metric to measure these kinds of things. And that new metric was called MTTH. Any guesses on what MTTH might stand for?
Mean time to Hitler?
You got it. Mean time to Hitler. So every AI tech should probably be looking at, how do you go to mean time to Hitler? And then, that is what is unfortunately happening. So that's one. Getting you to another example. This is a quote from Jeff Bezos. Jeff Bezos, when he was working on Wall Street, had this opportunity to go make a startup and go do something on the internet. And he was a very well-to-do Wall Street guy. The problem was he was not able to make a decision about what to go in for, continue his well-rewarding Wall Street job or go into this flaky internet new thingy that's coming out and do something about it. And he could not make a decision, so the way he thought about it was look backwards. And he said, what was I going to do if I was 80 years old and I looked back? If I looked back and I did not feel that it was an opportunity lost, then I would have done something different. But he came to the conclusion that he did not want to miss this new phenomenon called the internet and decided to build Amazon, and the rest is history. So this kind of a thinking process where you look back is called inversion. Inversion is basically turning a problem around on its head. And when we do that, we are trying to remove all the things that we know are not right and bring up the right things automatically. So inversion is one of the very capable models that we have that are extremely useful for site reliability. The biggest example that comes out of inversion as a model is fault injection. So how do you make a system strong? If you wanted to make a system very strong and capable of disasters and such, we intuitively think that we should make it stronger, right? Add more layers to it and so on and so forth. Inversion says, try to inject faults into your system, ferret them out, fix those faults, and then it will become stronger on its own. This concept is called making a system anti-fragile, right? And this particular model is very useful when you want to have a large-scale service that can sustain large amounts of impact. Another example that comes to mind for inversion is false alarms, right? I mean, false alarms are the bane of the SRE folks over here because you get woken up 2 o'clock in the morning and you have to deal with them. One of the ways that we think about false alarms the next morning is how can I make a better alarm that can do the job right? So the thing is, we do not realize that we need to reduce alarms. There's a tendency in us to actually add more alerts. We never, ever try to reduce alerts in our systems. So this is one of the things that we need to think about and remove certain segments of alerting that we think are more higher probability for false alarms nature. Another way we can actually look at it from an inversion point of view that Matt touched upon on his talk in Google yesterday is a risk. Risk is basically risk assessment is trying to look forward into your product and service and think about what can go wrong. And this in a typical manner is called a pre-mortem, not a post-mortem. A pre-mortem is if you died, what would happen, how can you think, how it can work out, and you try to get a list of those things and work them out in a logical manner, weigh them based on the risk criteria that you have, and then you're able to solve each of them properly. So it is another inversion tactic that is extremely useful. legendary person, Steve Jobs. Everybody hopefully knows about him in this room. No, he was not poor, that he wore the same clothes, the same kind of clothes from beginning till end, right? When asked about this clothing in his autobiography, he said he did it mainly to make a statement and to reduce cognitive load. He knew he did not have to worry about what clothes to wear in the morning or what clothes to wear when I'm standing on a stage in front of 100,000 people or whatever that might be. And he decided that that is what it's going to be. He is not the only leader or a famous person who has done this. Mark Zuckerberg is known for this clothing philosophy. And if you don't want tech people to be on that list, there is one very famous guy, one of the heroes of the entire world, Albert Einstein. It is said that he used to have only a few gray suits for him because he did not want to consume his brain power into thinking about other things. And no, I'm not asking you to dress like a uniform around over here, but I'm just giving you an example that this is how famous people try to reduce their cognitive load. This kind of a model is called decision fatigue. Decision fatigue is real. It's like playing this video game where you have mana on the left-hand side, and the more you do, it starts reducing, right? I mean, you played video games. So this is the same concept. Mana is real in us. When you are an on-call engineer, when you have to make a lot of decisions, and another high-pride incident happens at the end of the day, you are tired not because you were sitting on the same laptop for a lot of time. You're tired because you have to make decisions on a minute-by-minute basis, and that drains energy. So as an SRE, your goal should be to reduce decision fatigue. Of course, what I say over here is important. You should not go online shopping then, right? And the reason is you're going to reduce the decision-making power for your real work. 3 recommendations I have for that from SREs. Alert checklists are extremely important. Intuitively, when we think about checklists that we write, we think that they're going to be used by other people. That is what the purposes are. In my mind, they are for us as well, the person who actually wrote it. Because when you're woken up at 2 o'clock in the morning, your ability to debug a problem is not at the peak. You need to have a checklist to go through and figure out what can go wrong. And these are the steps that you had written down when you were in your full capabilities, and you could walk down through them and fix things appropriately. Simple routines. Try to keep your routines simple on an on-call day. Don't try to juggle between 10 different things you have to do and satisfy everybody. That takes a lot of cognitive overload, and you're not able to do anything properly at all. So, it's a difficult choice. Don't try to think between Starbucks coffee or Tully's or whatever that might be, and make that a problem. Third is limit your choices. Again, same thing. But when we try to go around, we look at fewer things, limit choices in terms of clothing as well, example. So that helps us be in better form and shape to do real things. I had something, yeah. Trick question for you. What's common between the chair, a spoon, and the pants? Trick question, so you don't need to answer. They're all in this room today, right? That's what I wanted to tell you. I mean, you may not have a spoon, so I was carrying one. I wasn't sure if I can't be false on that, right? There's another thing I can guarantee you. The same 3 things were here 500 years ago. These 3 things have not changed. They have remained the same. This concept is called Lindy effect by Taleb. So he says that there have been things in existence for a long period of time that can be considered more robust and anti-fragile because they have stood the test of time. And they will probably continue for a longer time as well. It's not that they're just going to die suddenly. They have become stronger as ideas and become stronger as entities, so they might not just disappear overnight. And this particular model is applicable to inanimate objects. So you can't say that Mohit has lived for 40 years, 100% he's going to live for another 40. Well, I don't know. Actuarial sciences might differ with that depending on what's my probability of heart disease and all that stuff, and it changes. For inanimate objects, Lindy effect says it's going to stay for a longer time, so you should keep that in mind and not let that bias your execution. What that means is local compute power is still relevant in this cloud-first world in general. And this cell phone that I have has more power than the laptop my parents have back at home, right? So client processing power isn't going down. Cloud and cloud infrastructure are great things for the right problem. As SREs, we need to make sure our expectations are balanced on each side of the equation, and we use all the resources appropriately. Second is one of my favorites is backwards compatibility. It's not technical debt. I mean, sometimes it can be. It's not a yes or no question, but if your service has been in production that you're making large changes to for the past 4 years, chances are you should make backward compatibility options within the new feature or the new version, because it is probably going to stay for 3 or 4 more years at least, right? So yes, we can call it technical debt later on, but it's going to stay longer. And another example that comes to my mind from this particular analogy is we still, after 40 years, have COBOL and Fortran systems running our most critical services around this planet. I mean, Visa, the credit card services, does not run on the latest version of Java or Node.js or anything of that form. There's a reason for that. It's not that they're stupid people. There's a reason how large, stable systems behave. A third is emails are still important. I may be an old generation guy for this particular opinion, but I feel emails are still relevant to our job. As much as the new tools are effective at what we are trying to do, the message that you want to take away is emails are going to stay, they're not going to go away, so try to make sure you're optimized for every possible thing. From a mental model point of view, these are the only things I wanted to cover without going into technicalities. What that means is this is the list that Kurt was talking about. But I only have 5 out of those. And if you wanted to stay for long, you will have to cancel your flights, and I don't want you to do that. So out of the 5, there's a lot to do, but I ask you to take action on 4 points. The takeaway for me, for you, should be number 1, self-reflection. Everybody has their weaknesses and their biases, and the way you tend to solve things. You need to be aware of what you are, who you are, how you behave, and this is something that you need to work out yourself. Matt had a great analogy yesterday when he was talking about risk. He mentioned that when he looked at risk, bees came to his mind the first thing because he's allergic to them. So we have our own weaknesses and strengths. I have my own strength. I am an infrastructure guy with network and DNS experience. I try to solve every goddamn thing with network and DNS, right? So we have our ways of doing things. We need to be cognizant of that. Second is practice. Practice is extremely critical. Decide what you want to do and practice it regularly. There is no shortcut for that. Decide which model affects you the most and try to come up with real-life examples and then make it work. Third one, multiple colored hands. Diversity is not a checkbox, okay? And the reason it is not a checkbox is we come from different backgrounds. Our bringing up was different. We come from different cultures. That means our mental models are different. The way we think about the same issue is a different way altogether, right? The biases that I might have, you may not have, and vice versa. So it is extremely important that for the success of the business and of the team, you need to have people who have different weaknesses come together and work out on the thing. I was trying to look for a different image for this one. I wanted to look at Avengers and say, if you look at all the superheroes in Avengers, each one of them has a different background. Each one of them has a different strength. They are from different places altogether. I mean, there are superheroes. We can learn from that and not try to look for a computer science degree all the time. Maybe the person who does it is the right person for the job. The last one is you should continue to look for unicorns. And when I say unicorns, they are people with unique abilities that can actually add value to your organization. The question you should ask is, why can't you hire the chef, the picture of the chef that I showed before? Why can't you hire a firefighter on an SRE team? Why can't you hire an airplane engineer? All of them bring different strengths, different ways of looking at it, and actually solve the problem the way you want, and it is going to be beneficial for everybody on the team. It's a huge topic. This is my reading list. If you ever are interested in understanding more about mental models, great list. The link below is this speech by Charlie Munger that he gave. very good to listen to. That is it. I'm out of time. Probably we don't have time for questions. You can reach me out at Twitter or my email address. I hope this was worthwhile, and thank you so much.